Did you know the sun's magnetic field flips every 11 years? Well, that's true. This dramatic event marking the peak of solar activity can have profound effects on Earth. In this video, we'll explore what triggers this polarity switch and whether it poses any dangers. We'll break down the 11-year solar cycle, explain the mysterious Hale cycle, and investigate how these magnetic flips impact space weather. Let's understand how these solar changes could influence everything from auroras to satellite communications. This phenomena occurs approximately every 11 years and is a significant phase in the solar cycle. The change in polarity shows the midpoint of solar maximum, the period of most solar activity, and the transition to solar minimum. The last time the sun's magnetic field changed its polarity was at the end of 2013. But what triggers this change in polarity, and is it hazardous? It is about time to take a closer look at the phenomena of the sun's magnetic field reversal and try to understand what consequences it may have for our planet. First of all, to comprehend the phenomenon of the reversal of the magnetic field, one should know what the solar cycle is. This is a cycle of about 11 years of solar activity and is associated with the magnetic field of the sun and the number and size of the sunspots. Solar maximum refers to the period of the solar cycle when solar activity is at its peak, and based on current projections, it is expected to happen between late 2024 and early 2026. There is another cycle associated with the sun, although not as famous as the previous one, known as the Hale cycle. This cycle takes approximately 22 years and consists of two of the better-known 11-year solar cycles. This is a period in which the sun's magnetic field changes polarity and then reverts back to the original polarity. Ryan French, a solar astrophysicist, stated that this cycle is quite interesting. At the beginning of this cycle, during what is known as the solar minimum, the sun's magnetic field is relatively uncomplicated and is similar to that of a bar magnet or a dipole like the Earth's. This means it has a clear north and south pole. However, as the cycle advances towards the solar maximum, the magnetic field of the sun becomes more intricate. In this phase, it does not have a clear-cut path between the north and south pole. However, the magnetic field lines are not straight but spiral and interconnect, which makes the pattern much more complex. The magnetic field of the sun reverts back to a simple dipole after a solar maximum has occurred. When it reaches the next solar maximum, the magnetic field looks similar to how it started, but with a key difference. In this case, the polarity is reversed. This means that what was the North Pole is now the South Pole, and what was the South Pole is now the North Pole. This 22-year Hale cycle assists scientists in studying the evolution and changes in the sun's magnetic field and its effects on space climate and solar activity. The next change in polarity will be from the north to the south magnetic pole in the northern hemisphere and vice versa in the southern hemisphere. This will take it to a similar magnetic alignment as the Earth, which has a south-pointing magnetic field in the northern region, French said. What leads to the change of polarity? Sunspots are the cause of the reversal of the sun's magnetic field. These are magnetically complex regions on the surface of the sun that can lead to major solar activities like flares and CMEs. CMEs are huge explosions of plasma and magnetic fields that occur on the sun. Sunspots occur in a pattern when they appear. If the sunspots appear near the equator of the sun, then the magnetic orientation will be the same as the old magnetic field. On the other hand, if the sunspots are formed closer to the poles, then the magnetic field will be equal to the new incoming magnetic orientation. This pattern is known as Hale's law, according to Ryan French, a solar physicist and the director of the Wilcox Solar Observatory at Stanford University, has more to this explanation. He states that the magnetic field from these active regions in which sunspots are found migrate towards the poles over time. This movement of magnetic fields ultimately leads to the flipping of the sun's magnetic field. This process of sunspot formation and magnetic field reversal is an important aspect in studying the sun and the cycles that it undergoes. The exact cause of the flip in the sun's magnetic polarity is still unknown. Scherer Phil, a solar physicist from Stanford University, said that this is related to the issue of explaining the solar cycle. He said that, at the moment, researchers do not have a clear mathematical description of what is going on during these cycles. It is difficult to comprehend the processes that are at work if there's no clear model to follow. One of the questions is what creates the magnetic field. Todd Hoeksema says that the behavior of sunspots is also critical. Researchers are still not very clear whether the sunspots will add to the magnetic field at the poles or whether they will neutralize each other at that location. This is a question that has not been answered yet. It is crucial for these scientists to comprehend these aspects of the sun's magnetic field and its cycles. It assists them in forecasting solar activity and its effects on space climate and the environment of the Earth. However, until researchers are able to come up with a more elaborate model, the causes of these magnetic flips will not be well understood. How fast is the transition? What we do know is that the flip of the solar magnetic field is not a process that happens in a blink of an eye. It is a continuous process that takes place throughout the 11-year solar cycle. It begins as a dipole magnetic field, increases in complexity, and then reverts to a reversed dipole. Ryan French also notes that there is no exact time when the sun's poles switch, unlike in the case of Earth, where the flip is characterized by the movement of the north and south poles. This reversal normally takes only about 1 or 2 years, although it may occur earlier or later. For instance, during the solar cycle 24 that ended in December 2019, the North Pole field was reported to have taken almost 5 years to reverse, as reported by the National Solar Observatory. The flip of the magnetic field is very slow, and you will not even realize it when it has occurred. However much it may sound like the end of the world, it does not mean there's an apocalypse. Phil Scherer goes on to say the world will not end tomorrow, but there will be some negative consequences of this polarity flip that we will have to face. These effects are typical for the changes in solar activity which occur during the solar cycle. What are the implications of the sun's magnetic flip? It is beyond doubt that the sun has been very active lately, releasing a number of powerful solar flares and CMEs which caused rather intense geomagnetic storms on the Earth and, consequently, magnificent aurora recently. But the intensity of space weather has been reported to have increased, and this is not the reason for the flip in polarity. Space weather is generally at its peak during solar maximum, and when the sun's magnetic field is also at its most complicated, says French. One side effect of the magnetic field shift is slight, but primarily beneficial. It can assist in protecting the Earth from galactic cosmic rays, high-energy protons, and nuclei that move at nearly the speed of light and can penetrate spacecraft and endanger astronauts in space who are beyond Earth's magnetic field. When the sun's magnetic field changes, the current sheet, a vast plane that extends billions of miles away from the sun's equator, becomes very undulating, thus offering a better shield against cosmic rays. Forecasting the strength of the next solar cycles. Currently, researchers are observing the sun's magnetic field as it goes through a critical phase referred to as magnetic field reversal. This is a part of the 11-year cycle of the sun where the magnetic field reorients and gradually goes back to a dipole configuration with a north and south magnetic pole. The rate of this reversal and reconfiguration is important for the level of solar activity in the next cycle. If the sun's magnetic field reverts back to a dipole in the next 1 to 2 years, then it means that the next solar cycle will be moderately active. This could mean more sunspots, solar flares, and coronal mass ejections, which can affect space weather and may interfere with satellite signals and power systems on Earth. On the other hand, if the transition to the dipole configuration is gradual, the next solar cycle might be less intense, like solar cycle 24. This would lead to less solar events and a period of relatively low solar activity. Knowledge of these patterns is important for anticipating the impact of solar activity on our technology and environment.